everyone. Thank you for taking the time to be here today as we will be presenting to you our project. We hope you enjoy the presentation. Globally, people are extremely eager to save time and money while maintaining healthy life choices, especially when performing essential activities such as in-store grocery shopping. Our project presents a system that integrates artificial intelligence methods with augmented reality techniques to enhance the grocery shopping experience through the use of smart glasses. Our proposed framework deploys a convolutional neural network object detection model that allows for item identification. By simultaneously retrieving data from a large nutrition database, personal medical reports, and other grocery store-related datasets, our intelligent system is able to provide user-centric nutrition facts, health and wellness tips, and unhealthy selection warnings that are augmented on a real-time broadcasting of the smart glasses. Our initial plan was to purchase smart glasses and have our framework installed on it. This would require multiple visits to the grocery store to test our framework. However, due to the pandemic limitations, we had to switch to an alternative solution, which is the live broadcasting, as it does not require as many visits to the grocery store. When the user is hand-holding or facing an item at the grocery store, our system instantly detects it, labels it, and starts the flow of every data set related to that item. In order to achieve that, we use the convolutional neural network object detection model, which is the DUNet. For such model to be able to recognize objects in the scene, it has to be trained on a large visual dataset containing labeled and bounding boxes annotated items. We first created a shopping list of 11 randomly selected food items, keeping in mind the availability of each item in the Nutrition IX dataset. Nutrition IX is the dataset from which our system will be retrieving nutrition facts regarding each selected item. It is true that it is the world's largest verified nutrition database containing millions of grocery store items. However, one thing to mention here is that it is slightly limited when it comes to Canadian brands. Our list also contains non-food items to extend the flexibility of our framework. Our dataset contains training and testing videos for each of the items on the shopping list, keeping in mind that some of the selected items were placed on the shelves individually, such as the cheese, while others were placed as a group of items such as the pineapple. Both videos were filmed using a smartphone camera that was held from behind that mimics the experience of the user wearing a pair of smart glasses with a mounted frontal camera. The training videos, as seen in the first video here, are focused on filming the item from different viewpoints and depths, while the testing videos are the actual shopping experience of the user facing the item, grabbing it, and placing it in the shopping cart. Now, an important point to mention here is that all the test videos were combined into one video for the testing process. Once we had our in-store dataset ready for the training and testing processes, we deployed the object detection model DUNet to predict the object's labels and bounding boxes through the use of supervised learning. Now that we obtained the labels by the object detection model, we will pass it through the other components or agents of our framework. In order to display the most important nutrition elements based on the user's current health condition while warn them against others, we created the Nutrition Data Analysis Agent. Our nutrition agent contains two lists. The first list contains a set of items that are unhealthy for the user, and upon the detection of each one of them, warnings will be displayed along with a suggested healthy alternative. We also created a list of thresholds for nutrition elements that are most important for the user's health. That will enable our system to color-code the key nutrition facts based on the user's current health condition. CoShopper system increases the cost efficiency of the grocery shopping experience through the deployment of the discount deals agent. For that reason, our system retrieves discount deals data from a sample list that we created containing the item information, the original price, and the discount offer. The reliability of our framework is also increased through the use of the barcode and QR code reader. This feature will be active when the detection of the item does not run as smoothly as it was intended. What do we recommend our system to progress towards? First, unfortunately, compared to other progressive countries across the globe such as Sweden and Finland, Canada is still behind in providing citizens a convenient access to their medical records. However, in recent years, more and more Canadian health organizations are working with the government on creating systems and online platforms where Canadians can access their health information whenever they want. For example, Life Labs in Ontario currently allow patients to view their results and access their medical records anytime they want. Another example is MyChart, which is an internet medium that is being used in most hospitals in Southern Ontario, currently allowing patients to have a permanent access to their medical records. These recent changes could open the door for an autonomous transfer of medical information from platforms like the ones we just mentioned to a framework like CoShopper. However, this has to be a consented process that honors the privacy of individuals and prioritizes security of information.